Hello and welcome to this tutorial on finding the inrush current into a DC machine. When you start your studying of DC machines, finding the inrush current is one of the first questions you tend to get asked in an exam or a test, and they ask that because it requires a bit of an understanding as to what's going on whilst minimizing the calculations. So what we'll do is we'll go through here and I'll show you how you can find these. The questions will often give you a lot of information, particularly if I'm setting the exam. I often give more information that's necessary. So let's pretend we've got a question that says that the armature resistance is, say, 0.5 of an ohm. The armature, the field resistance is, let's say, 1.5 of an ohm. The armature, being a big coil of wire, will also have an inductance, and let's just say that that's say 1.5 millihenries, just to put a number on it. And the field will also have an inductance, and let's call it 4 millihenries, just for the purposes of the calculation. And being a machine, it's inrush current, it's obviously operating in motor mode. We need an input voltage there, so we'll just say it's 300 volts, just for the purposes of this. Now, it doesn't really matter in terms of solving this from first principles whether it's connected in a series or a shunt mode. We'll go through the series one first because that's the one that's slightly more complicated. Okay, so if we look at a series one, we know from previous work and also the other tutorials that I've put up that the equivalent circuit for a series machine is going to have our field winding here, which naturally has a resistance and an inductance component to it. There's our field winding resistance and our field winding inductance, and that will come down, and it's in series, so we will have our armature resistance here, our inductive component to our armature, and then the idealized armature here. And there's your basic circuit. Now, things get real easy quite simply because we can go through and we can get rid of half these terms. We know that the reactance to an inductor is 2 pi FL. This is a DC machine. There is no frequency there. That term goes to 0, which means that term goes to 0. And because of that, we don't have to worry about this or this. Both these terms go to 0. We can also see from looking at this that using some basic first year equivalent stuff, we know that the voltage here, our input voltage, which we've called 300 volts, is the sum of the volt drop, or the voltage here, which we call the back EMF, the volt drop across here, the armature, the volt drop across the armature, and the volt drop across the field here. So we can say that the voltage here is equal to the field voltage plus the armature voltage plus the back EMF that's going to be generated in the machine. So that's our first lot of simplifications, and that's quite simple. Now, we also know that the back EMF in the machine that's going to be generated here is machine constant times the flux times the speed in radians per second. Now, when we first turn the machine on, and its first inrush current, the machine is going at 0 RPM. Yes, that'll change very soon as the machine starts going, unless it destroys itself, as some of these calculations will show. But at the moment of turn on, the rotational speed is 0, so that term goes away. 0 times the flux, doesn't matter what it is, times the machine constant, doesn't matter what it is. 0 times anything gives 0. So our back EMF term goes to 0. So we only now have our input voltage being dropped across the field resistance and the armature resistance. And that's a series circuit, so we can rearrange that very easily, and we can say that it is the current times the resistance of the field, because as you know, V equals IR, plus the current times the resistance of the armature. And we can rearrange that equation there quite easily. We can pull both those current terms out to that. We can rearrange that to make current the subject. We've now got a solution. We want to know that. We know what that is, we know what that is, we know what that is. So now we can just plug the numbers. And it's 300 over 0.5 plus 1.5, because we're given those. And of course that gives us a solution of 150 amps. 150 amps is a lot of current, quite possibly enough to destroy the machine, which is why the way we start a DC machine is not simply to slap the power on it if it's a decent sized machine. And I'll talk more about that in another tutorial. Now, if we wanted to go through the same process, but we wanted to look at a shunt machine, or alternatively a separately excited machine, because both of these can be looked at in this way. Again, we can draw our equivalent circuit. We have our field here, our armature. So that is for our shunt machine. If it was separately excited, we would have our field over here. Now, I do these two together because for the purposes of looking at inrush current, it doesn't matter. We're looking at the current down through here, through our armature. This is the current we're interested in. And we've got our voltage supply here. What's going on in the field doesn't matter. So we can just forget about all that. It doesn't matter. And similarly, how this is being excited over here, it doesn't matter. So we don't have to worry about that. What we're interested in is our armature resistance, our armature reactance, and our back EMF. As I said over here, our armature reactance doesn't matter, so that goes to 0, and what we're left with is we're left with a very simple circuit of that, for a simplified, where this is our armature resistance and this is our input voltage. Our back EMF, we already know, goes to 0. So our solution, our voltage here is our current and our resistance. We can rearrange that. And we now have our solution. We know what we want. We've got all our values. We can simply plug the numbers. Our armature resistance we said was half an ohm. So we would get a solution of 600 amps if it was a shunt machine. Again, 600 amps is certainly enough to destroy a machine, so we won't be starting it by basically just throwing a big switch. Okay, so what we've done is we've gone through here and we've looked at how to find the inrush current into a couple of configurations of a DC machine. Thank you for watching. I'll be putting up some more of these tutorials, taking advantage of the lockdown that we're in to do this, and look forward to seeing you and seeing you again. Thank you very much.